Let's welcome Bambi.
Thank you. I'm so excited to be here, and I appreciate that you are all still here. I know it's been a long conference, so I appreciate that you're all still here. I have a lot of fun videos for you, so I think it'll be worthwhile. If you have questions as I'm talking, feel free to raise your hand. I would always rather answer a question than have you get to the end and find that you've been confused for 45 minutes. So by all means, let me know. So Jens told you a little bit about why I'm here today, but I did want to let you know, so I know that I am, I think, the only person from industry, who does an industry job day to day, who is here, but my background, as Jens said, was in educational robotics. Now, I originally started in rehabilitation, so my PhD work and my work as a faculty member was in robotics after stroke and traumatic brain injury. So working with people, and as I decided I did not like being a professor and left that, I went into educational robotics, and as Jens said, I spent a number of years working with Tom Lowers at BirdBrain, which I loved, and he just ran out of engineering for me. So at the end of 2021, Tom and I kind of saw this coming, and he was helping me think about my next step. Everyone should have when they come to the end of a job, everyone should be so lucky as to have their boss helping them find their next one. And as we thought about what I enjoyed spending time on, what I had done, we realized that the thing that really motivated me and that I had done over the course of what looked like a couple of career changes already was looking at how non-experts can use robots, be they individuals with disabilities who are using robotic systems or kids and teachers. That's what I really find very interesting. How can we make it intuitive for people who didn't build the system to use a robot? How can we make that easy and engaging and approachable? So as I was interviewing around, I ended up at Agility Robotics because they recognized that they had kind of an issue. They had a very complicated robot, and they wanted it to go out in the world, and they didn't know how to do that because the robot had never been out there. It had never been worked with by anybody who wasn't either a member of a research lab or an engineer at the company. And so it turns out that educational robotics is an excellent background for that because it's one of the only places where people who aren't experts have already been using robots for years, where teachers and students who don't have any background have been doing that, where we have enough data to know anything really about what it takes for anyone to use a robot. Most robots that you see in the news or things are still in the research phases or in early deployments, but they're mostly being used by the engineers. And I think educational robotics has a lot of lessons to offer that area as people start to think about what does it look like for your robot to not be in your facility, but to be out in the world with people who aren't using it. So this isn't a great picture, but it's the only one I had with BirdBrain's Finch and Digit in it, which is why I included it. We were talking to those kids and we were using them to talk a little bit about what all robots have in common. So all robots, be they very small or very large, kind of sense their environment and do some processing to think about it, in quotes, and then act. And that's the same for the little ones and the big ones, though as Digit, as we'll go on to see, does some of those things in a pretty complicated manner. So today I want to talk a little bit about big fancy robots and how we can expand who can program and work with them. So I am going to talk about a few ways that are related to programming, but not exactly the same thing. And I really want to focus on what we can do to make it easy to use them. So I'm going to use a variety of case studies. I have some kids, an artist, the office manager of the Pittsburgh office, whoever I could round up to be my victim as I was experimenting with doing this. So that we all know what it is that I'm talking about. So this is, I joined Agility in January of 2022. So basically, this is the robot that greeted me when I arrived. So what this robot does, it is designed to do work in warehouses. So to pick up totes, I actually do not need that sound, so we'll just get rid of, oh, that. I'm going to assume that's not my sound. Just to be clear, that is not the background music for this YouTube video. So it is designed to do warehouse logistics tasks, basically what you're seeing it, to do the boring work of moving totes from one place to another place so that humans don't have to. So moving it from those blue shelves are called flow racks because the totes kind of fall down them. So moving it from flow racks over to the conveyor, moving it from one conveyor to the other, that kind of boring, repetitive task that it was really hard to fill right now because nobody really wants to do it. And I don't blame them. I don't walk into a middle school classroom. It's my new favorite question to ask in middle school classrooms. Who wants to move totes for 8 hours a day? There are no volunteers. So, and it's very hard, of course, on the human body. I'm sure many of us know relatives who've done that or similar work, and it's not easy to do for a long period of time. So how Digit is doing this, you will have no doubt noticed it is a walking robot, so it does not have wheels. As Jens was asking me earlier, it does walk over a variety of surfaces. So it's on flat ground. It can do gravel, a couple of steps, a ramp. If you throw random 2x4s on the floor, but I wouldn't recommend doing that in your warehouse. It's not good practice for your humans. But all of those are fine. And it is orienting itself using those black and white tags that you can see there in the picture at the bottom. Those are called April tags. They're used by a number of other people. That's just the name for those patterns. Each pattern corresponds to a number. And so Digit looks for those in the environment and has an internal map of where those appear. It, as you have no doubt noticed, does not have a head in this version. That kind of blue thing on the top of its shoulders is LiDAR. So it is using the laser to avoid obstacles. And there was probably, I think there was a picture somewhere in there of kind of what it looks like. So this is kind of what the robot's view of its environment looks like, where it's using the LiDAR to see where there are obstacles that it should avoid. And so it's just very simply grasping things between we call them end effectors, or you can call them fists, between the endpoints of its arms and moving them. Now, all of those problems in and of themselves are really hard, particularly walking on a variety of surfaces, but really all of them. There's nothing on that list that's super easy. And so at the end of 2021 and coming into 2022, this is basically what the company looked like sometime in the fall of 2021. I think a few people are missing, and I don't know where they are because I've never seen our floor that clean. I can only assume that they had just moved into the office. But the only people who were programming the robot at this point, and not even most of the people in this picture, but engineers largely with master's or PhD degrees. They were all working in Python C. They were all extremely good at coordinate transformations for reasons you'll understand in a few moments. They've read a lengthy user manual, but even after you've read the user manual, so I started my first week, I dutifully read the user manual. I started it up. I could not do anything. Turns out there's a lot of things that weren't in the user manual that were largely delivered via word of mouth. So Martin is one of the people in the back row who was sitting next to me who got to answer a lot of questions for me about how you really program this robot, because there were a lot of visual cues that are there but weren't in the user manual. So we were growing very quickly. So in January of 2022, was employee roughly 60 something. As of this week, they're probably roughly 225, 230. So we had a serious, how do we onboard people problem. So our first training problem was not training people outside our company. It was training people inside our company. So I had been at work about 3 weeks, and I decided that there were 2 new people starting in the Pittsburgh office, and I would at least train them so Martin didn't have to tell them exactly the same thing that he had told me 3 weeks prior. So I was interested in how to make their lives easier because I'd already seen that it was difficult to program this robot. And I was already starting to find myself in kind of like all good projects, perhaps it kind of began with an argument. because I was definitely hearing from some people, well, programming is just hard. It's a robot, it has to be hard. There's nothing that we could possibly do about this to make it easier. Now, I think all of you being educators used to the ideas of scaffolding and helping people learn would largely dispute that argument, but I was hearing it from a number of sides. So I kind of started my work with Snap as kind of a proof of concept. Does it have to be this hard? I bet it doesn't. I bet if we tried hard, we could find a way to make it easier. And probably learn some things from that about how to move forward with making training, with training people. Oh, I pressed the wrong button. So as I started to train some colleagues who were starting, we all learned to do basically the same thing. So some things you learn first to do with Digit. As you see the little balls that are appearing on the wall, those balls appear when Digit recognizes a coordinate frame. So what people are learning to do, they're learning to set up coordinate frames, and then they're using to find the boxes, to pick them up, and to take them over there, or really anywhere. This one's going to take it over to that table. And so I started out doing this in person, and later we got an online system so that they didn't have to fly me to Oregon every one time someone new started in Oregon. Much better for both me and the people in Oregon. So, but here are Jack and Curran, who are in Oregon in April of 2022. And that is, they have learned, everybody learns in simulation. It's much safer than learning on a real robot. And then runs their code in the real world. So he has been through training, and he is kind of picking up his box and moving it over here. I think at the end you will get to see how excited Curran is when this finally works. As this has been at this point, yes, see there, Curran is very excited because at this point, this is like a 3-day process to get to this point. So I'm there in person. You talk a lot about coordinate transformations and asynchronous programming in Python, and eventually you get to this point. And as we started to have materials available, it was interesting that we were starting to get interest from new people. So the other gentleman in that video, the blonde, was Jack from our support team. And Jack is not on the software team. He would not have ordinarily gotten training, but I was going to Oregon anyway, and the support team asked if they could sit in. They're getting questions from customers on the software, and they didn't know how to help, because most support problems were your robot is broken. Jack is very good at that part. If your robot is broken, he is just the person you would like to take its legs apart and put it back together for you. But he didn't have any Python programming experience. He wanted to sit in and give it a try. And I noticed as he was doing it, he was doing Python a lot like block programming. He was not worried about what that big block of Python code said. He was like, well, Bambi told me this moves the robot somewhere, so I will just copy the whole thing, put it down here, change the numbers, and the robot will go to this other place that I want. Which was working pretty well. Like, it was a pretty effective way to do it, but it made me start to think, like, I bet that we actually could use blocks instead of Jack moving chunks of asynchronous Python code around in this file. And what that would look like in making the robot more accessible to members of our own team who aren't the software developers. So the other thing I learned is that coordinate frames for basically everyone, there might be 1 or 2 exceptions who have math degrees or are particularly wonderful at coordinate transformations, but the part where you set up the coordinates was by far the hardest part. Theoretically, you can put your April tags anywhere. So what happens is you put up your April tags and you set up a coordinate frame by telling Digit the coordinates of those April tags in your imaginary coordinate frame that you want to set up. And if that didn't make any sense to you, that would be the experience of most of us when we hear that for the first time. And you could set that coordinate frame to be anywhere, 6 miles down the road and rotate it at 37 degrees. But in fact, most people don't want to set it anywhere. Logically, if you've put 2 April tags on the wall, most likely you would like your coordinate system to be halfway between them. Or if you have 3 April tags, you probably want it on the one in the middle. So as I was training people, I was training, I was using sample code, and I started to wonder, like, am I just training them to do it my way? The way I like best. And I think in most cases I was. Most people just learned to do it the way to mimic my convention. So they weren't setting their coordinate frame anywhere. They were setting it where I always put it. That's not really different than if we just automatically set it in a place. Like if no one is using the ability to set it anywhere, then I question whether it's useful to have that ability in the software. So I started to think about, are there ways that we could simplify this setup by removing some of those choices? Now, I know sometimes that makes people like hyperventilate a little bit about removing choices, but choices that you don't know how to use are not necessarily amazing choices for you. So sometimes it's better to have some structure that helps you figure out how to get the map you want, rather than engage in a 3-day discussion with me about coordinate transformations. So there are, of course, a lot of block-based options. For us, Snap was a great choice because we already had a JSON. Our underlying API is in JSON, so it was very easy to call those. I'll wait for Jens to take his picture. Did enable us to easily prototype blocks that use JavaScript. And in addition, I did want the stage. I know a lot of robots and things also use Blockly. In this case, I actually did use the stage because I was using it to help people configure the environment. So I swear this is probably the only part of this that requires you to actually think about what's actually happening here. But how it works is that each robot, either the actual robot or the simulated robot, because they perform identically, or as close as we can make them to identical, is hosting its own server. And you control that robot by sending commands in JSON to its server over an IP address. Now, for the simulator, that's a locally hosted address. For the robot, it is like a real address of that robot's server. Now you cannot send any command that you would like. And in fact, the API is limited to fairly high level commands. So for all walking robots, much like all walking humans, have to balance themselves over their feet. Digit will not let you give it any command that will make it unstable. It will just reject those. Now, if you pick up a box or something, it will shift its weight automatically to maintain over its feet. But there are a lot of things it won't let you do because it basically considers its feet to be none of your business. You cannot tell it to take one step forward with its left foot because for safety reasons, the control loop is always in charge of that low level code. So we are already, we have a variety of engineers who work at different levels. So there are people who work on that control loop. There are people who work just on perception with the cameras. What we call applications engineers or skills engineers, those people who work on making the robot do things that it will do at customer sites, are already using a very high level version of the API. They're not telling it what foot to move. They're telling it, Digit, go over there. Digit, pick up that box. Digit, go over to this location in the map. So there's a good amount of abstraction there that we can build on. So I did not have to start with like somehow running the control loop in Snap. That is definitely not what is happening here. I'm using a high level API, and that comes with that safety layer so that I'm not going to issue commands that will damage the robot. Sometimes we use the gamepads for remote control just if we have to run it into place at a demo or something, but basically any computer is using those JSON commands to interact with the robot, and it in turn is sending back information. I made it to that position. I didn't make it to that position because I haven't got a clue on Earth where the April tags are. I didn't make it to that position because I fell down, whatever it might be. Hopefully, it's usually sending you back a success message, but if it's not successful, it'll send you back something else. Usually, our engineers use Python or often TypeScript now to issue those JSON commands. I instead replaced that with Snap. So I'm doing kind of the same things, but I'm using Snap instead. So as you can see, I am using the stage here in Snap, and it's basically collecting the information that it needs to set up that coordinate frame for you. So rather than asking you to compute all of the information that it needs to set up that coordinate frame, it is telling you, put the April tags at the end of your table and then measure the width of your table. It's also asking you some questions about your box. That version of the robot needed to know how large your box was and how heavy it was. So it's kind of walking you through that process. And then it's automatically setting up a convenient coordinate frame that's at the center of the table. That's why it asks the width of the table as well, so it can put that coordinate frame nicely in the middle for you. So it's a standardized origin and orientation. Sometimes if I'm working with people who are new to it or kids, I even have little straw coordinate frames with different colored straws. I will go and set in the middle of the table so that we all remember where the origin is. So after you've entered that information, you've basically defined table types and box types, and you can use the snap blocks. First, you need to tell Digit what you're looking for. And that is true also in our Python code. You basically have to tell Digit what's in the environment. And once you've told Digit what map you're using, or what, in this case, what table and box you're looking for, then you can issue go-to commands based on that map and tell it to pick and place objects. Now, the blocks have parameters for the April tags. So you can add, if you add new tables that are the same size with different April tags, that's fine. You can use the same table type. You don't have to reconfigure all of that in the stage. And similarly, if you have a bunch of different boxes. So you only need to define table types and box types, and then you just tell it the April tag number. And so I was using this for a few things. This is the corner of our office before we'd really moved into the lab downstairs. I was running Digit around up there. And before the SNAP conference last year, I tested this with my delightful and long-suffering office manager, Brianna, who is always up for helping out with whatever weird experiment I've decided we're running that day. So she is testing this out, and it took her about 33 minutes from the start of me explaining what was going to happen to her picking up blocks. So this is like 2 months after it took Curran and Jack basically 3 days in Python to reach that point. And she was really like, she was kind of excited. I mean, she'd seen the rest of us wandering around picking up boxes with these April tags. So she was interested to know what it was that the rest of us were doing all the time. And I will say she is very talented at coordinate frames, Brianna. I was quite surprised when she told me she hadn't had a math class in a while, because she did get that part quite quickly. But she was really found it pretty straightforward. It walked her through the steps. She was able to get up and running and move the box. And so I was using this as well. Most engineers, and I'm still training engineers, do need to do it in Python, but I found it really helpful for them to go through this process, particularly our interns, because the chunks of the program are the same in Python. You still need to look, you still need to set up your environment. You still need to look for the box, tell the program what you're looking for before you try and go to any positions, or before you try to pick and place boxes. So I went through that as I was training people to give them a general idea before we got caught up in the minutia of what all that Python syntax had to look like. So actually, while I was out in Oregon that time training Jack and Curran, I noticed this woman randomly painting on the wall over in the facility. This is Agnieszka Palau. She does not work at Agility. She is an artist who has worked, whose specialty is kind of art about technology. She has worked with Spot from Boston Dynamics. I think she's currently doing a show in Australia of that work. And she had approached Agility. We don't pay her. She in fact she does not pay us. She pays her own lodging and travel. And she had asked to come to the facility and paint Digit. There was also an augmented reality thing going on with that piece there. I thought that looked pretty interesting, so I just went over to figure out what she was going on. It's one huge bay out in Oregon. And